Well, Jason, thank you very, very much for a great presentation. And so what I'm going to be doing, folks, is I will open up the Q&A and ask Jason the question, and he'll respond. So let me start with the Q&A. And so the first question is, Jason, how soon do you expect extreme winter weather to trigger climate migration? Is it already happening?
I think extreme weather from climate change is already causing this. Now, I focused a lot on the cold extremes. There are also very warm extreme. One of the things I didn't talk about was that actually right during when we were having the super cold wave here in the southern plains, Europe was having extremely warm conditions. It was extremely warm across Europe. They were having record highs for the month of February. So yeah, I do think that extreme weather related to climate change, or these bouts of extreme weather, are probably already causing some forms of climate migration, and probably will amplify as we go into the future as the weather gets a little bit weirder and more extreme.
Okay, very good. Let me unmute myself. Hold on here. So our second question then what's your opinion of sequestering carbon in soil by shifting to regenerative practices? We really have to look at how we reduce carbon with the carbon emissions in all forms. And that can be through looking at more renewable forms of energy. Carbon sequestration is also a huge way to do that. So I'm kind of like a put it all on the table and let's see what we can do, because we do have to reduce our carbon emissions within the next 10 to 20 years for sure. Yeah. Thank you. Our third question then is, what do these changes in the polar vortex mean for sea levels?
That's a good question. So in terms of sea levels, the depletion of sea ice right now, that's not really affecting directly. It's not affecting the sea levels. However, there is some recent evidence that some of this melt that's happening, especially over Greenland, is actually causing the Gulf Stream to slow down. That's not just a polar vortex connection, but it is a climate change connection. And the slowdown of the Gulf Stream could absolutely start to affect sea levels, especially across the east coast of the United States. So it's all kind of interwoven together with sort of this climate change polar vortex kind of thing.
So one of the things I noticed on your map, that's an interesting point, that there was a large area of cold on those global maps just around the St. Lawrence Seaway, where it emptied out into that part of the Atlantic.
Yeah, let me go back real quick to show that, because that's a great, right here. This is what we've scientifically technically called now the cold blob across the North Atlantic, and that's what it is. It's melt coming off of Greenland that's causing the temperatures to cool. But that's also a huge area for our Gulf Stream, and also something we call the thermohaline circulation, which is sort of this conveyor belt within the deep ocean, and that should actually start to slow things down.
Okay. Yeah, interesting. Very good. Okay, so one of the questions that was raised is, how do you respond to this happens normally every so many years comment by people who don't accept climate change?
So the thing with climate change, the way that I like to think about it is, it's not a single event. It can be hot or it can be cold one day or 2 days or even a week. It's the change in the frequency of these events that are the hallmark of climate change. So it's not so much that, it's reaching 90 degrees in Oklahoma or 100 degrees in Oklahoma. It's how many days per year are we hitting 100 degrees? And that number is going to go up, or is going up, and will continue to go up. So it's not a single, it's the overall frequency or trend in the event that you're talking about. That's the important thing that you need to highlight when you talk about climate change.
Okay, very good. So with respect to the, and I'm assuming this question is referring to the polar vortex and that extreme weather events, what would you say is when you talk to people, how does this affect humans on a daily basis?
Oh, that's an excellent question. That could be a whole other talk.
these polar vortex events, these extreme polar vortex events have huge, I mean, we saw it here. I mean, we saw infrastructure fail. We saw, unfortunately, some people did lose their lives due to loss of water, loss of heat. But this does cause significant health risks, safety risks. Huge things can happen. There's been several studies that are emerging now about sort of mortality rates during these extreme polar vortex events. And we do see an uptick in sort of health and mortality risks as these events happen. So we talk a lot about heat, but cold events are also very important for the safety and health and mortality.
Mm-hmm. Yeah, very good. So there's a related question. December 1983 was very cold, and I'm assuming here similar to what we just experienced. Does data, if available for them, don't know if data was available, but then would there be a similar occurrence with the polar vortex?
Yeah, that's a great question. Yes, there was another weakened polar vortex event during that time. In fact, some of the results that I'd shown a plot on these changes in cold air outbreaks that are happening across the plains. And one of my PhD students is actually looking at each of these events. The 1983 event and the 1989 event also is within there. That was another major one to happen. We've been investigating that and linking that to changes in the stratosphere. And we see similar signals that are happening as well.
So what's interesting too is looking at your description of weak and strong polar vortexes. I grew up in Pittsburgh, and one of the things I remember is the 60s were always really cold and snowy.
Yep.
You know? And that fits that pattern.
Yeah, no, absolutely. And, it's both the polar vortex and other patterns within our climate system. And that's why I said sometimes we get sort of these perfect storms of patterns that get together to form cold winters, even as the overall climate is warming. So you can get something within that trend. Not everything is linear. It's not just every year gets warmer and warmer and warmer. You can get sort of dips and amplifications too.
Sure. Well, here's a question I think is interesting too. How far back in time can we track polar vortexes actually via proxies?
Yeah, so that's a great question. So there are paleoclimate studies that have looked at, not at the polar vortex directly, because that's in the stratosphere, so we don't have anything up there, but looked at different proxies to measure sea level pressure trends across the North Atlantic, because those actually respond to changes in the polar vortex. So it's sort of like a chain kind of thing. The polar vortex causes changes in the sea level pressure across the North Atlantic. So if we could measure that, we could get a proxy of the polar vortex strength. And yes, there are paleoclimate records to look at that as well.
So wasn't that the movie The Day After?
The Day After Tomorrow was actually about that overturning circulation that I talked about in the ocean.
Yes.
And so the slowdown of that is huge. And so a lot of people, I don't know if people have seen some of the news media on it, but they've been talking about Day After Tomorrow scenario of that, because this thing is slowing down as we now see.
Yeah. And they picked it up with an ocean buoy initially.
That's right. Yeah. And we have those kind of measures right now. That cold blob is telling us that things are slowing down. I mean,
so let me ask you, you should be able to pick that up from tree rings also, from dendrochronology, can't you?
Yeah, dendrochronology is temperature and also precipitation. So there would be a connection. Again, we'd have to draw correlations between sort of the storm track and those things as well. Yeah.
Okay, very good. So our next question is, I recall meteorologists and climate people a few years ago talking about a ridiculous resilient ridge that created a warm zone stuck over Alaska for multiple years even. Is that at all related to those tongues of distorted polar vortex that reached on, or is it some fairly unrelated phenomenon?
That's a great question. As always, it's multiple things. So the polar vortex played a role in that, but also areas in the tropical Pacific as well. So sea surface temperatures in the tropical Pacific and also rainfall patterns there also project onto the Alaskan area too. So it's a combination of the two.
Okay. So relating, there's an interesting question here about mixing. Does the polar vortex take ozone up to the stratosphere?
So actually what happens is that ozone is actually produced in the tropical regions. And then there's actually a large scale circulation in the stratosphere that actually goes up in the tropics, out and actually comes down into the polar regions, and that's where we get our ozone in the polar region. So ozone actually is formed within the tropics and gets exported out.
Oh, okay, very good. Okay, I'm still looking through the chat. You may have addressed this. Does the disruption of the polar vortex cause the wavy jet stream, or is it the reverse?
So another great question, because those heat fluxes the heating that goes in, a lot of that is caused by storms, and storms are caused by sort of these waves that are occurring within the jet stream. So again, it's one of these things where there's waves that are occurring that are amplifying that heat, disrupts the vortex, and that sort of then kind of feeds back and causes even more waviness to sort of happen. So the biggest bang for the buck comes from the breakdown of the vortex, but there is there is initially a little bit of waviness that is going to happen.
So I'm going to follow up on something like that. Jason, I'm assuming there's no southern pole vortex.
Oh no, there absolutely is. So both hemispheres, these are wintertime features. Again, these are natural climate features. So the polar vortex exists because of nature. There is one in the southern polar vortex, though, is actually very strong. It does not get disrupted very often. And in fact, it was one of the reasons why we had we had our big ozone hole during the 80s and 90s. CFCs. But the other reason in the southern hemisphere particularly is because the vortex was so strong that it actually caused destruction of ozone within the vortex that even decreased it further. So less intrusions down there, but they do happen. In fact, last year in Australia, if you remember the big droughts and wildfires that happened, part of that was related to a breakdown of the southern hemisphere polar vortex.
Interesting. Okay, very good. Very good. Okay. Let me go ahead and read down through these. Is it still predicted that the blue blob area, like for example, the British Isles, will be colder due to ocean currents? And in the long term, will it warm again?
So again, so this is exactly sort of related to the polar vortex question, is that we should start to see, even though winters are getting warmer, they're probably going to be a little bit of a blip downward as this circulation slows down, and it causes maybe slightly colder weather to start, or neutralize the trend, not let it go up as much over the next, I don't know, maybe decade or two. We'll have to see how fast that it slows down.
So you were talking about the fact that, we would see what comes forward in the next 10 to 15 years. What are some of the projections for what the vortex will do?
So yeah, it's very mixed. Some of the climate models actually predict that the vortex should start to strengthen rather rapidly, which would mean that the cold air would start to retreat and we would start to warm very rapidly. Others keep it in this more disturbed kind of state, and so keeps us, sort of takes us out eventually, but we still do have these punctuations of extreme winters here and there happening over the next 15 to 20 years or so. But again, the reservoir is getting warmer. So even cold weather 20 years from now is not going to be as cold as it was, say, 50 or 60 years ago.
And all that, and one of the other mitigating factors you also talked about that showed up on one of your first slides was volcano and volcanic events moderating some of that. Obviously, Krakatoa, when Krakatoa went off, back when it did, that disrupted global climate for a long time. How are volcanic eruptions being looked at that, given what's going on currently?
So volcanic eruptions are a little difficult because they're very, very hard to predict. In fact, probably unpredictable. They're very short-lived. So even the big ones like Krakatoa or Pinatubo tend to have an impact over just, say, 2 to 4 years maybe in our climate system. One of the other impacts that we do take a look at, or some have taken a look at, is actually impacts of solar cycles, so sunspot cycle, and how that may have a minor effect on the polar vortex strength. And so some people have actually been kind of studying that as well.
Okay. So right now, as you know, the Southern High Plains is in a drought. And La Nina is blamed by local weather people. Is there a relationship with the polar vortex and the La Nina, El Nino events?
Certainly it didn't help. So, I mean, when we get these events, and I would say not so much here, but in the northern plains,
they are super dry up there. And when this big extreme weather event happened, it got really cold up there, which they're used to, but it also suppressed all the storm activity to the south. That's why we were getting snow and ice all the way down to the Mexican border, whereas the northern plains was extremely dry. And so the storm track was just suppressed so much. And so really, I'd be worried about expanding drought coming not just regionally, but also in the northern plains as well.
And I'm assuming, based on what you show with the map, part of the reason we are so susceptible are the Rockies provide the eastern slope of which that weather all slides down.
That's right. Cold air is dense.
Yeah,
so
that's
it cannot go west. I mean, you go to western Colorado, it's a much different winter than they've had in eastern Colorado. And actually, that's going to happen this weekend. Denver's supposed to get almost 2 feet of snow as we get cold air rushing down in the Rockies that are going to bank up against there.
Yeah, interesting. Oh. So we are going to be on this side, on the eastern side of the Rockies, much more susceptible because of the fact that there's nothing blocking that cold just rushing down.
Nothing. Once the door opens from Canada, the cold air, there's nothing that can stop the cold air from bleeding southward into the plains, essentially.
So one of the things that I remember, so I went to get my PhD in Calgary, and they always talked about there when I was up there in the late 70s, early 80s, about the movement of the Arctic front. And when the Arctic front would go south, then you get this rapid change in weather for that whole part of Canada. And that always occurred around a particular period in October. I'm just wondering whether it's related to what that vortex is doing.
Sure. So the jet stream, our jet stream, our storm track migrates north and south during the winter and summer. So during the summer, it's going to be placed across, far north. That's where the storm track is. As we head into the fall, that starts to dip further southward, and so that allows these bigger intrusions. That's when the polar vortex starts to strengthen too, is during October, because by the time you get to October, it's dark in the Arctic, so it can cool down rather rapidly. And you get that thing to form and cause this jet stream to start to strengthen as well.
Okay. So there's another question. South Florida was one of the only places in the U.S. that wasn't greatly impacted by the winter storms. What prevented that?
So the direction that this particular cold air outbreak, which also made it a little unique, but a lot of it came right down the center of the country and just went south. It expanded a little bit east into Mississippi, Louisiana, parts of Alabama, Tennessee, but it never swept all the way to the East Coast. Right. It kind of came straight down and that's it. And so, on other years, typically these things come down and they expand rapidly eastward. And so you'll get freezes down to Orlando, you get the orange groves will be frozen and things like that. That just did not happen this year. The pattern just kept everything pretty much funneled right in the center of the United States.
Interesting. Let's see here. I'm looking at both chats and question and answer.
No problem.
So this is an interesting question. Looking at climate as dynamic energy and assuming decreased energy into the polar vortex, where will the extra energy released by CO2 go?
So the idea here is that as the temperature change weakens, we may get less. There may be less storms. So storms feed off of this difference in temperature. So the bigger the temperature difference, the bigger the storm grows. If this temperature difference weakens, we might expect that we won't get as many storms. But what could happen, and some of the models are saying, is actually we get fewer but bigger storms. So we get more extreme. So rather than getting a rainfall that sort of comes over the season over multiple storms, we may get our rainfall in 1 or 2 big fell swoops kind of thing, sort of just use it up and get done with it. And that's actually a form of extreme weather. Certain areas cannot handle, are not designed to handle a season's worth of rainfall within, 2 to 3 weeks or something. So
no, I couldn't imagine Lubbock getting 18 inches of rain in one.
Yeah, in one season, right? We say it's a rainy season, not a rainy week, right? It's a rainy season.
Yes. So one of the questions in the chat is there any correlation between the 30+ years without a below average month and the increase in fracking? I mean, what in terms of how we relate input to the atmosphere and what you see?
So, I mean, we know that as we increase greenhouse gases, the quantity of greenhouse gases, and that's just not carbon, that's not just carbon dioxide, that's also things like methane, nitrous oxide. As those gases increase, temperatures will warm over the whole globe. So any increased emissions, which could come from fracking, which could come from increased industrial activity, any of that type of stuff is going to cause less or more above average, less below average years into the future.
Okay. So can you explain a little bit to us why the Arctic is warming faster? Because that's a major part of this whole issue.
Yeah. So in the Arctic, the whole globe is warming, right? But in the Arctic, it also has this really delicate balance where it has ice and snow that should be there that helps to regulate how much sun and how much warmth can happen within there. And as you start to deplete the snow and ice because it's getting warmer, that opens up things to start to absorb more solar energy. So that causes it to get warmer. Plus, something I didn't really talk about, but also because the Arctic Ocean is getting more open, you're allowing more water vapor to go into the atmosphere, which is also causing more cloudiness. And clouds act as a blanket, or they help to trap outgoing energy from the Earth's surface. So not only can you get more energy in because of less ice, but you're also trapping the outgoing part, or the part where the Earth tries to cool itself gets trapped more. And so that imbalance causes a net gain in energy. And if you gain more energy, you warm up. So that's why the Arctic, because of that delicate balance that was there before, is now depleted, and it's causing this cycle. And so it's sort of like the snowball. Maybe snowball is a bad one, but the ball going down the hill. Once you push it, it's going to keep going down the hill, right?
Mm-hmm. So one of the things that I think is I'm curious about too, from what the models and what the maps have shown. Why in the center of continents, if you're having this issue with the polar vortex moving, why do you see some parts of the globe getting cooler rather than warmer?
Yeah. So especially in the northern hemisphere,
right?
As you get within the Arctic, the maximum cooling over the last 30 years at least, the maximum cooling trend has been over like central Siberia area. That tends to be away from the coast where you get the warming influence from the ocean. So again, typically those oceans should be ice covered, so it should be really cold, but as you open the ocean, it'll warm very quickly on the coast. So the interiors will cool down faster because you could actually start building up a little bit more snow cover in the interior. So that'll help it to cool a lot faster. Similarly, here in North America, it's not going to be northern Canada because that's the part that should be ice covered, like down into Hudson Bay and across that whole area. But instead, it's going to be where that vortex moves, and it tends to move further southward into the central part of the continent where it's going to get colder.
Okay, very good. So a couple more, we have time for some more questions. Looking at climate as dynamic energy and assuming decreased energy in the polar vortex. Oh, I think we answered.
Yeah, we answered this one. Yeah.
Okay. So what about winds? Will winds actually increase?
So that's a good question. Globally, it depends where you are. So if you're under one of these big meanders where you're under one of the big ridges, you're not going to get much wind increase. But if you're in the storm track where things get stuck and you're in one of these big troughs, winds are going to increase in that area.
To what degree would you see the Southwest drought getting worse in the coming 20 years?
Yeah, so the Southwest drought is actually a huge thing. It's controlled not just locally, but also by tropical Pacific sea surface temperatures. And right now, 20 years might be a little hard, but right now we definitely have trouble over the next, say, 1 to 2 years. If the monsoon does not kick in again this year, like it didn't last year, it's going to be some serious problems down there. And some of the signs are suggesting that could be the case happening again this year.
So if you were, and this is, I'm asking this based on one of the comments.
Yeah.
If you were talking to the governor of Texas, what would you talk about weatherizing energy infrastructure?
Yeah, I think we have to plan. I think we have to plan for these extremes.
this event was an extreme event. It was historic, but not unprecedented. And I think that's an important thing to sort of to make the distinction that it's historic, no doubt, but it's not unprecedented. And so we need to be ready and weather aware. And Texas is really unique because not only is it the cold waves, it's increase in hurricane activity, it's increase in drought across the western part of the state, especially increase in heavy rainfall events. Houston, especially now, we've been seeing year after year this increasing trend on heavy rainfall. All these things are things that we have to get ready for. And so we should be investing now to get ready to protect people and property coming up over the next 10 to 20 years and more.
Okay. So we have a couple more questions in there. So let me go ahead and pull this down. So there's been some discussion in the news too about tornadoes. So what's the prognosis for tornadic activity?
So the signals right now, La Nina years, which we just came out of a La Nina, and there's some indications it could linger and actually have another La Nina next winter. There's still a little question mark on that. But springs that follow La Nina winters tend to increase storm activity across the southern plains. So more incidents of hail and tornado across Oklahoma, Texas, Arkansas, Louisiana area. And that has to do with the low-level jet, which pumps warm air in from the Gulf that helps to feed these storms. That amplifies during La Nina years. So this year, we should actually, the prognosis, and I agree with it, is that there will be an increase in severe weather across a lot of the southern plains.
And I've noticed too, Jason, that there's been some discussion about that boundary between the arid west and the mesic, more humid east, moving further east. So that tornado belt is the tornado belt actually moving eastward?
It is. So yeah, with time, we've been noticing that tornado frequency over the last, say, 20 to 30 years. You might have, like, Tornado Alley is iconically across Texas, Oklahoma, Kansas, up into, Nebraska, Iowa.
Right.
But there's been a trend now where it's been, I guess, more towards the east, towards the Mississippi River Valley, more Tennessee, Arkansas, Louisiana. It doesn't mean we don't get the storms here. It just means the frequency has been increasing to our east. And a lot of that has to do with that dry weather, that boundary coming in, plus the change in the low level, that jet stream pumping in the humid air, warm humid air across the southern Gulf states.
Okay. And I think we have time for one more question. And so the writer asks, is the Hadley cell impacted from climate change? Is it expanding?
Yes. So the answers are yes and yes. So the Hadley cell, for those that are not familiar, is it's rising motion in the tropics, moving air towards the poles, and then sinking right about, say, 30 degrees north. That's why we get our high pressures there. That's why places like Hawaii have, fairly tranquil weather, because they're under this region of high pressure. As climate change is happening, that up part where it's being fueled by convection, that's strengthening with time, and that's causing the cell to expand with time. So dry regions are expanding further out from the subtropics into the lower middle latitudes, basically.
Okay. So when I grew up, those were the horse latitudes.
Yeah, that's fair enough.
Yeah, very good. Well, Jason, thank you very much for the presentation and the great Q&A. This has been phenomenal. And thank you all for the people that have asked questions. Please continue to stay in touch and keep us posted about information, and we will keep you posted also. Mackenzie, any final thoughts?
I just want to thank you so much. This was a perfectly timed event. Jason, we appreciate you coming out for us, and thank you for this topic.
Thank you. Thank you for having me. I love talking about this, and I had a great time discussing it.
This will be recorded and posted on our YouTube page. You can follow the Climate Center on Facebook, YouTube, Twitter, Instagram, and more, and you will have that link if you visit us on social media.
Okay.
Bye, everybody. Thank you all.
Thank you.
Bye. Thank you.
Bye-bye.
Thank you.